Welcome to today's deep dive. So our mission today is mapping out this really exact science-backed blueprint for building a rock-solid, deeply rooted bond with your dog.
Yeah, and it's an incredible topic because it really challenges a lot of what we think we know.
Totally. We're pulling from a massive stack of behavioral research and neurobiology studies,
Mhm.
and all our sources point toward a very specific guide for you to build this strong bond with your pet.
Right, and it actually has very little to do with, being the alpha or buying the absolute most expensive treats on the market.
Yeah, which is kind of a relief, honestly. Instead, the data overwhelmingly focuses on two core pillars, which are radical consistency and creating a profound neurological sense of safety.
It's just a phenomenal collection of research because it completely dismantles those old school methodologies. I mean, the ones we all grew up with.
Right, the whole dominance theory thing.
Exactly. We are looking at a fundamental shift here. We're moving from viewing dogs as subjects we just command to viewing them as these highly sensitive observers that we co-regulate with.
Co-regulate. I love that word for this. But to understand how science actually arrived at this perspective, we kind of need to start with this deeply personal story. It really sparked a major chunk of this modern research.
Oh, the Gregory Burns story.
Yes. So it revolves around this neuroscientist named Gregory Burns and his pug, Newton. And for like 15 years, Burns and Newton shared this incredibly quiet, unassuming life together.
Which is how most of us live with our dogs, right?
Right, exactly. We are talking about basic daily routines, morning walks, sitting silently on the couch together while Burns read, just enjoying the proximity.
Being near each other.
Yeah, but eventually Newton passed away, and Burns, well, being a literal brain scientist, found himself utterly haunted by this seemingly unanswerable question.
Because the dog can't just tell you how they felt.
Right. He kept wondering, did my dog actually feel love for me, or was I just like a giant hairless food dispenser?
I mean, it's the ultimate cross-species communication gap right there.
It really is.
We humans rely so heavily on explicit verbal confirmation of affection. Like, we need someone to say, I love you. So when an animal cannot speak, it is incredibly easy to fall into this cynical trap.
The trap of thinking it's just a transaction.
Exactly. You assume their attachment is purely transactional. You give them calories, they stick around.
Right.
But because Burns is a neuroscientist, he didn't just write a journal entry about his grief and move on. He actually spent the next several years designing rigorous peer-reviewed tests to figure out what is literally happening inside a dog's brain.
And the very first step in answering whether it's love or just food anticipation is understanding how a dog actually selects their favorite person in a house.
Right, because everyone always argues about who the dog loves
Oh,
most.
totally. Because the immediate assumption, if you just watch a dog interact with a family, is that they just follow the person who drops the most table scraps.
Or the one who plays with them constantly.
Exactly. Maybe they prefer the person who gets down on the floor, uses that high-pitched baby talk, and, throws the tennis ball for 2 hours straight.
Which is what trainers often refer to as the fun parent misconception.
A fun parent, yeah.
Humans assume animals prioritize this immediate, high-energy gratification. But the behavioral data reveals that dogs are actually these exquisite pattern recognition machines.
Wait, pattern recognition machines?
Yeah. In a domestic household, they do not consistently bond most deeply with the unpredictable source of excitement. They bond most deeply with the person who is the absolute most predictable.
Okay, let's break down the mechanics of that predictability because it's fascinating. If I think about human relationships, right? The friend I want to take a stressful cross-country road trip with.
Let me guess, it's not the party friend.
Definitely not. It's not the chaotic friend who buys a round of drinks and then just disappears for 3 hours. It's the steady friend.
Right.
The one whose moods and reactions I don't have to constantly, calculate. I imagine for a dog living in a human world, that calculation really takes a toll.
It takes a massive neurological toll, actually. You have to consider the cognitive load placed on an animal that does not speak our language.
Yeah, they have no idea what we're saying most of the time.
Right. They can't read a clock, and they have literally zero control over when they eat, sleep, or go outside.
Wow. When you put it like that, their lives are entirely up to us.
Exactly. The human world is inherently chaotic for them. They're in this constant state of anticipating what happens next.
It's waiting for the next cue.
So when a human's behavior, tone of voice, and daily rhythm are completely consistent, it drastically reduces that cognitive load. The dog's nervous system stops releasing cortisol.
Which is the stress hormone, right?
Yes, the stress hormone. It stops releasing it because there is no unpredictable threat to scan for. To a dog's brain, predictability is the literal definition of safety.
Okay, so a lack of surprises allows their nervous system to finally just power down. But behavior only tells us part of the story here.
Sure.
If consistency creates this internal feeling of safety, What does that safety physically look like when a dog actually has to navigate a challenge? The sources highlight this major study out of the University of Vienna that tested this exact dynamic.
Oh, the Vienna study is brilliant in its methodology.
It really is.
They basically wanted to measure how a human's presence affects a dog's problem-solving abilities.
Hmm.
So they brought dogs into a lab and presented them with these interactive puzzle toys.
Like those complex plastic boards, right, where the dog has to slide panels and lift lids to find hidden treats.
Exactly. And they tested the dogs under several different conditions. First, they had the dog try to solve the puzzle completely alone.
Okay.
Then they had the dog try to solve it with a complete stranger in the room. Then, with their owner present, but actively encouraging them, cheering them on. And finally...
And this is the crazy part.
Right. Finally, with their owner present, but sitting there completely silent and completely ignoring the dog.
The outcomes across those variables are what make this study so vital. I'm looking at those outcomes, and I'm honestly tripped up by one specific detail here.
The silent owner result.
Yes. The dogs persisted longer, worked harder, and solved the puzzles much more successfully when their owner was in the room compared to when they were alone or with a stranger. That makes sense.
Right.
But the data shows they performed exceptionally well even when the owner was sitting there doing absolutely nothing.
Literally just sitting there.
Yeah. If I'm sitting in a chair entirely ignoring my dog while I'm just scrolling on my phone,
Huh.
how is my lack of participation actually helping them solve a complex physical puzzle?
I know, it seems completely contradictory because we, as humans, equate assistance with active intervention. Like, if I'm helping, I'm doing something.
Right, I'm pointing at the puzzle piece or whatever.
But the mechanism at play here is a psychological concept known as the secure base effect. And this wasn't actually discovered in dogs first.
Where was it from?
It was originally observed in human infant psychology.
Oh, wow.
Yeah. When a toddler is placed in a totally unfamiliar playroom, they don't just immediately run to the toys. They take a step, assess the room, and they look back at their parent.
Checking in.
Exactly. The parent is the secure base. The parent doesn't have to demonstrate how to use the toys or even speak a single word. Just having that known, predictable entity in the room acts as an environmental buffer.
So the presence of the steady human acts like an anchor for them.
Precisely. From a biological standpoint, the physical proximity of the secure base suppresses the infants,
Yeah.
and in this case, the dog's amygdala.
And the amygdala is the fear center of the brain, right?
Yes. So when fear is suppressed, the prefrontal cortex finally has the bandwidth to engage in higher-order thinking.
Like figuring out how to manipulate a puzzle toy to get a treat.
Exactly. By simply being a predictable presence, you are absorbing the dog's environmental anxiety. They realize, hey, my steady human isn't panicking about this strange laboratory room, so I guess I don't need to either. It gives them the neurological freedom to be brave.
I mean, that shifts the entire paradigm of what it means to support your dog. You don't have to micromanage them at all. You just have to provide the infrastructure of safety.
It's passive support, but incredibly powerful.
But again, behavioral observation was really only step one for Gregory Burns. Like, seeing a dog solve a puzzle faster doesn't definitively prove they feel an emotional connection, right?
Right, it just proves they feel safe.
Exactly. He wanted to know what was actually happening inside their bloodstreams.
And that takes us from the psychology of the secure base directly into the chemistry of attachment. Specifically, this amazing thing called the oxytocin feedback loop.
Yes, the sources outline this fascinating biological mechanism triggered by mutual gaze. So when humans and dogs look directly into each other's eyes, both species experience a significant spike in oxytocin in their bloodstream.
And oxytocin is, colloquially known as the bonding hormone.
Right.
It plays a massive role in mammalian social structures, mostly in dampening stress responses and fostering trust. It is literally the exact same chemical pathway that activates when a mother holds her newborn baby.
Which creates this sort of compounding chemical cycle, right? Like, the dog looks at you, your oxytocin levels rise, which unconsciously softens your facial expressions and your tone of voice.
Yeah, you relax.
And then the dog registers those safe cues, which causes their own oxytocin levels to spike, which then prompts them to gaze at you even longer.
It is an infinite loop of social reward. It just feeds itself. But the evolutionary context here is what makes this finding so extraordinary.
Because it's not normal for animals, right?
Not at all. In the broader animal kingdom, and particularly among canines, prolonged direct eye contact is almost universally perceived as a threat.
Like a challenge for dominance.
Exactly. Don't stare at me or we're going to fight.
Yet our sources emphasize that this oxytocin loop with humans is a total biological anomaly. Researchers actually replicated the mutual gaze experiments using wolves, but wait, not wild wolves.
No, they tested wolves that had been hand-reared by humans from birth.
Okay, so they were used to people.
Very much so.
Uh,
These were animals socialized entirely within human environments, fully accustomed to being handled and fed by people every single day.
and the results.
The results were completely flat. Even wolves raised from infancy by humans do not initiate sustained mutual gaze to seek help or affection.
Wow.
Their biology simply does not trigger the oxytocin loop when making eye contact with a human. They physically lack the neurological hardware for it.
I mean, that completely eliminates the idea that this is just some learned behavior from growing up in a human house.
Totally.
Over tens of thousands of years of domestication, dogs biologically mutated. They literally hijacked human maternal neuropathways. They evolved the ability to chemically bond with an entirely different species just by looking at us.
It is arguably one of the most successful survival strategies in all of evolutionary history. I mean, look how many dogs live in our houses today.
True. But Gregory Burns still had one final hurdle, didn't he?
He did.
Blood tests showing oxytocin spikes are definitely compelling, but to definitively answer whether his dog Newton loved him or just loved food, Burns needed to see the brain actually processing these stimuli in real time,
He needed functional MRI scanners.
which means putting awake dogs into an MRI machine, which sounds, frankly, nearly impossible.
Oh, it's incredibly difficult.
Anyone who has ever had an MRI knows it is this intensely claustrophobic, incredibly loud experience. The machine produces these deafening, mechanical clanking noises.
It's terrifying.
Getting a dog to just sit still for a regular photograph is a challenge. How on earth do you get a dog to voluntarily endure an MRI without sedation? Because sedating them would completely shut down the brain activity they were trying to measure in the first place.
Right, you can't drug them. So the methodology here was actually a masterclass in establishing that exact secure base we discussed earlier.
Okay.
It took months of systematic desensitization. Burns and his team literally built a mock MRI scanner in his living room,
Just right in the living room.
right there in the house.
Right.
They started by simply playing recordings of the scanner noises, which were like 95 decibels, but at very low volumes while the dogs ate.
So pairing it with something good.
Exactly. Gradually, over time, they increased the volume. Then they trained the dogs to walk up these stairs into the mock tube and just rest their chins on a custom-fitted foam block.
That's a lot to ask of a dog.
It is. They shaped the behavior over hundreds of repetitions, always ensuring the dogs knew they could just get up and walk away at any moment.
So they weren't trapped.
Never. They relied entirely on the dog's absolute trust in their handlers to overcome the environmental terror of that machine.
It worked. When they finally got the dogs into the real MRI, they focused their scans on a specific region of the brain called the caudate nucleus.
The caudate nucleus. It is densely packed with dopamine receptors.
What does that do in humans?
Well, in human brains, this region lights up brilliantly when we anticipate something immensely pleasurable. Like, it could be the anticipation of eating a totally decadent dessert, or the anticipation of reuniting with a loved one you haven't seen in years.
Okay, so while the dogs were perfectly still in the scanner, the researchers presented them with two different signals. One signal meant a piece of hot dog was about to be delivered.
A very high-value treat.
Yes. And the other signal meant their owner was about to step into view and offer verbal praise.
Now, if the cynical theory held true, that dogs only view us as food dispensers, the caudate nucleus should have only shown significant activation for the hot dog.
Right.
The human praise should have barely registered at all.
But the scans showed the exact opposite, didn't they?
They really did.
In many of the dogs, the caudate nucleus fired just as intensely for the verbal praise as it did for the food. And in roughly 20% of the dogs, the social reward, the praise from their owner, actually triggered a massive spike that completely dwarfed the response to the hot dog.
That specific data point is the definitive answer to Burns' question. It proves that the neurological joy a dog experiences from interacting with their human is completely distinct from digestive anticipation.
It's not just hunger.
No, it is genuine, measurable social love.
And the researchers even backed up the brain scans with a physical behavioral test, right? A Y maze.
Yes, the Y maze is great.
They placed the dogs at the base of a Y-shaped hallway. Down one path was a bowl of high-value food, and down the other path was their owner sitting in a chair. They let the dogs go, and the vast majority of them immediately bypassed the food to run straight to their human.
The brain scans predicted the physical behavior perfectly.
It's amazing. But I do want to dig into a little nuance here, though. The data shows some dogs had equal responses, and some highly preferred the human. But I imagine someone listening right now is staring at their golden retriever, fully aware that their dog would absolutely bulldoze them for a dropped piece of cheese.
Oh, absolutely. There's always the cheese factor.
Does the research account for dogs that are undeniably completely ruled by their stomach?
It absolutely does. The researchers plotted the dogs on a spectrum. Because just like humans, dogs possess distinct personality profiles.
They're individuals.
Right. Some are profoundly motivated by social connection, and some are deeply biologically motivated by food. But this is where the concept of energy matching becomes crucial for building that bond, regardless of where your dog falls on the spectrum.
Energy matching. When the sources bring that up, my immediate instinct is to think about physical stamina. Like, if you adopt a high-drive working dog, say a Belgian Malinois, you basically need to be a marathon runner to match their energy.
That's the common assumption, yeah.
Yeah. But looking deeper at the research, energy matching seems to be much more about emotional regulation than just physical output.
Definitely. I mean, physical exercise is a baseline requirement, sure, but true energy matching is about regulating the nervous system. Dogs are constantly monitoring our emotional state to determine how they should feel about their environment.
Like the secure base again?
Exactly. If you have an incredibly anxious, highly reactive rescue dog, and you respond to their barking by becoming frantic yourself.
Like raising your voice, getting agitated.
Right. If you do that, you are amplifying their internal chaos. You are actually matching their dysregulation.
So instead of mirroring them, you need to be the emotional counterweight.
Exactly that. For a highly anxious dog, energy matching actually means providing a profound, unshakable calmness. It goes right back to the predictability principle.
They need you to be stable.
Yes, they need you to be the grounding wire that absorbs their frantic energy without short-circuiting.
And what if you have the opposite? A really lazy dog?
Conversely, yeah, a sluggish or disconnected dog might need an owner who provides steady, gentle enthusiasm to bring them out of their shell. The deepest bonds form when a dog realizes your emotional state, reliably compensates for what their own nervous system lacks.
Which brings up a highly practical question for the listener regarding the timeline of all this. We've talked extensively about evolutionary biology, oxytocin loops, and these deep-rooted neurological pathways.
Heavy stuff.
Very. And the sources emphasize that early life, particularly the puppy socialization window, is a critical period for forming these attachments.
It is a major window.
So if someone listening right now just brought home a 6-year-old rescue dog with an unknown, potentially traumatic past, is the neurological window closed? Like, is it too late to build that profound caudate nucleus lighting bond?
No, and the data provides an incredibly reassuring answer to that. While the puppy socialization phase does lay the initial foundation, mammalian brains possess a feature called neuroplasticity.
Neuroplasticity.
Yes. The brain is not a static organ. It physically remodels itself based on new experiences throughout its entire lifespan.
How does that actually work in the context of an older dog learning to trust?
Okay, think of neural pathways, like trails in a forest.
Okay, I can picture that.
If an older dog has a history of trauma or neglect, the pathway in their brain that expects unpredictability and danger is like a very wide, heavily trafficked dirt road.
It's their default reaction.
Exactly. And the pathway for trusting a human, that one is completely overgrown with weeds. You can barely see it.
Because it hasn't been used.
Right.
Yeah.
But neuroplasticity means that every single time you provide a predictable, safe reaction, every time you feed them at the exact same hour, every time you use a calm voice when they actually expect you to yell.
You're clearing a little bit of brush off that trusting pathway.
Yes, exactly. Over weeks and months of repetition, the trusting pathway becomes the new default road. And the trauma pathway, it begins to grow over from disuse.
That takes so much pressure off the human, too. It means you don't need to overcompensate by smothering a new rescue dog with grand gestures of affection.
No grand gestures needed.
You just need to systematically prove day after day that your reactions are entirely predictable. You build the infrastructure of safety, and the dog's neuroplasticity allows the affection to follow naturally.
The biology will absolutely do the heavy lifting once the environment feels secure.
Man, that's beautiful. So to pull all these threads together, we can confidently return to Gregory Burns sitting in his quiet house, wondering if his 15 years with Newton the pug amounted to anything more than just a transactional feeding arrangement.
A lot of us have wondered the same thing.
For sure. But the rigorous scientific evidence we've explored today offers a definitive answer for Burns. And for anyone listening who loves a dog,
Yeah,
yes, your dog profoundly, fundamentally knows you.
they really do.
They don't comprehend your career or your name on a birth certificate, but they know your unique scent, they know the daily rhythms of your life, and they know the specific energetic weight you bring into a room.
And that's what matters to them.
Exactly. Building a rock-solid bond with them is not about dominating them, and it's not about being the most entertaining organism in their vicinity. It is entirely about being a safe harbor in a chaotic world.
That's the core of it.
The connection you share is not a trick of domestication or just a convenient habit. It is a genuine, measurable biological tether. The oxytocin surging in your bloodstream is mirroring the exact same chemical surging in theirs. It is love built into the literal architecture of your brains.
It really forces us to elevate the concept of having a pet into a true biological partnership.
It really does.
And looking at all this data leaves us with a final, I think, really fascinating implication for you to consider.
Oh, what's that?
Well, we have empirically proven that over thousands of years, Dogs physically evolved to hijack our human maternal pathways.
Right.
Their biology mutated specifically to trigger our protective and affectionate instincts.
Hmm.
But biology is rarely a one-way street.
Okay.
Given how intensely our own oxytocin levels spike and how deeply our nervous systems co-regulate with their presence, we have to ask, how much is human biology quietly adapting to the animals we bring into our homes, generation after generation?
Oh, wow.
We assume we're the ones domesticating them, but in the quiet language of shared glances and predictable routines, they are undoubtedly rewiring us too.
What a profound mechanism to realize is happening every time they just, look at you from across the room. The MRI proved it, the blood test confirmed it, and the connection is as physically real as anything we experience. Thank you for exploring the mechanics of this bond with us today. Keep observing those patterns, keep providing that safe harbor, and maybe go give your dog a very predictable, exceptionally steady pat on the head. We'll catch you on the next deep dive.